no one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Ahad Cove. He's a software engineer at Deloitte and a YouTuber, and he has made something so awesome that I had to have him on the show. How are you, sir?
I'm doing pretty well. How about yourself, Sean?
I'm doing all right. I went and looked at your YouTube when you kind of like went low-key viral. I love your thumbnail of you're actually in the garbage can. It's a self-driving garbage can that takes itself out. And you made a picture of you, a thumbnail of you in the trash can driving it. That definitely must have helped your success.
Yeah, definitely, for sure.
I need to work on my thumbnail game because it's definitely not at that level. So I do a lot of Raspberry Pi stuff. And like for me, Hello World on a Raspberry Pi is like flashing a light, making an LED blink. Mm-hmm. Does a Raspberry Pi manage your entire self-driving garbage can?
It does in a way. It handles all of the driving and the braking and everything like that, but it doesn't handle the vision.
Okay. So it's a two-part process. So walk me through the problem, why this is a crisis in your life that needed to be solved, because that's how all good IoT projects start, right? There's a problem.
Of course.
You got to fix it. And then explain the pieces.
Okay. So for me, I pretty much hate doing any type of household chores, so inside or outside. So even just doing anything like taking out the trash every week is a big bother for me because, I'm a coder and I like to keep things dry. Dry stands for do not repeat yourself. So I try to put that aspect into my actual life as well. For anything that I can do, I try to make sure that I can do something repeatedly through coding or through electrical engineering in this case. Mm-hmm. So do you want me to go through the process right now?
Yeah, I'd like to understand it because like what you're saying is like the best developers are lazy. And that's very true. Very true.
Right. So it all started when, one week I had to take out the trash and it was really early in the morning. I kind of missed it the night before. So I had to wake up around like 6 a.m. to take it out. And I was so bothered by that. I was like, I have to solve this issue because this is a crisis in my life. It's an actual issue.
You couldn't just take it out the night before.
I couldn't.
Gotcha.
So I looked at my trash can. I actually got two trash cans because when I got this house, I rented this house out. I had two trash cans and one was mine to keep. So I basically just demolished it and took it apart and figured out what parts can I put a wheel inside. So I tried to do a lot of research online. Couldn't find much. I know there's some YouTubers like Colin First. He did. He basically replaced his trash can with a wheelchair inside of it. And he was like driving that around, but that was a little overkill for me. So I wanted a little e-scooter motor that I could just put inside the trash can to just drive out and then drive back. I set out on that journey to start creating it.
Oh, so when you think of a trash can, and for those who are overseas, maybe you're not in the US, it would be like a wheelie bin. It's a wheeled trash can. They lean back. They kind of like, they don't have four wheels. They have two, and you kind of like pull it back like a, what's the word? You pull it back like a dolly.
Yeah.
Right. So it leans back and they've got two big wheels. So you replaced one of the wheels with an electric scooter wheel.
No, actually, I basically cut out the front of the trash can and basically inserted a wheel inside that front of the trash can. Yeah.
So there's three wheels.
Yeah, there's three wheels on it. So,
smart. Okay.
Yeah. Originally, I was thinking about replacing those back two, but then I would have to put some type of wheel in the front anyway to keep it upright because it can't move without having something in the front of it as well.
Smart. Okay, so this doesn't have to lean back then. It just is on it. It's a tricycle.
Exactly.
Okay, I dig it. Okay, so you've got a electric scooter there, but like a Raspberry Pi can't handle that kind of voltage. That's a lot of work. So you're going to need batteries and all kinds of other stuff.
Right. Yeah. So the motor that I had was it's a wheel. They call it a wheel hub motor because it actually has the motor inside the wheel rather than having a motor outside the wheel moving the wheel. So basically, it has everything in one. And some of them even have a brake system inside, but those ones are pretty rare and is really hard to find. So mine had basically a manual brake system. But yeah, so that wheel hub motor takes up to 36 volts. And a Raspberry Pi can only output 5 volts on its own through the GPIO pins. So, of course, I had to come up with another way of having an external battery, which it's pretty simple in electrical engineering projects where they have an external battery outside of their computer. So, yeah.
And is that is your background in electrical engineering and software engineering?
It is not. It's just in software engineering. Electrical engineering is my hobby.
Oh, okay. So this is where I want to dig in on this a little bit because I feel comfortable at the 3.3 to 5 volt kind of place. Like I can make a light blink, but I still make mistakes like, hey, this isn't working. Oh, well, you're looking at 3.3 volts, not 5. Or, you popped this LED because you pushed too much voltage through it.
Right.
And then when you start thinking about 36 or getting up towards what we have on the mains here in the US, which is 110, you're going to get shocked.
Right.
And I always I don't want to do things I'm going to get shocked. Is there any concern about that kind of stuff, or that you're going to burn up the Raspberry Pi by putting the power through the wrong thing?
I mean, in the beginning, there was a lot of concern, but as I kept growing, I obviously didn't start with a project like this. This project is too big for, starting as a beginner. So I kept building up. One of my first projects I ever did was just a cat feeder. So it just opened up the little pipe that I had, the PVC pipe, and then closed it. So it was just connected to a servo motor. So you start off small and then you keep building from there. So you learn things along the way. And even with this project, I learned a ton. I learned a crazy amount with this project. I haven't even used a step-up converter before until this project. So, you keep working your way up.
Okay, so that's really good to know. Like you're not a degreed electrical engineer, so you didn't come like born knowing how to do this, which means that the software engineers that are listening to the show could maybe take their experience to the next level from flashing LED to cat feeder to self-driving trash can.
Right.
Okay, so you said a step up. Can you talk about stepping up and stepping down and what that means in the context of the voltage here?
Yeah, so a step-up converter and step-down converter will basically step your voltage up. So how you mentioned earlier how Raspberry Pi can output 3 to 5 volts. So say you need application outputs 10 volts. So you can put a step-up converter inside that circuit to step up that 5 volts to 10 volts or 12 volts or whatever you need it to. And that kind of basically allows more applications to be connected to your device.
But you've got a limited amount of voltage. Like you cut your amps down when you lift your voltage up. So at some point, like we've already acknowledged, the Raspberry Pi is not where the power is coming from. So where this is plugged into the wall, or do you have a giant battery in here?
Yeah, I have a 36 volt battery. It's a lithium ion battery. So that battery basically splits and connects both to my Raspberry Pi, my wheel hub motor, as well as my brake system. It's a servo motor that basically manually pulls the brake. So it's three different things connected. Yeah.
The battery, interesting. So naively, and I emphasize naively because I have no idea what I'm doing, I would have probably had a battery for the Pi, a battery for the motor, but then it would have been more things to charge, I guess. Exactly. And you're able to run all that on one battery.
Yeah. Most of the time you want one power supply. If your circuit can handle it. If it can't handle it, then, you may need 2 batteries. So yeah, for me, I want to keep things as small as possible and condensed because it can only fit inside that small slot inside the trash can. And the more space it's taking up, the less trash I could put inside of it. So you got to think, for saving space as well.
Interesting. Okay. So you've got a 36 volt hub motor. That's the one with the motor and the wheel are kind of the same thing, which is very clever. Then you've got the battery that's also conveniently 36 volts. And when you pulling off a little bit to run the Pi and pulling off a little bit to run a servo or other things like that, did any of that affect the power of that wheel to pick up the trash can and move it on its way?
No, nothing that I noticed. The voltage will always stay the same, at least from my understanding, no matter how many things you have connected to it. It's the amperage that normally will be drained. So the amperage from the Raspberry Pi doesn't take up much at all. I can't remember the exact number, but
yeah, I think
that
it's
number
like an
is
amp,
very
maybe.
small. Yes, it's probably
nothing.
something like that. Yeah, so I wasn't worried about that too much at all. So if it did take anything, it took a tiny bit, not enough.
Well, that's actually a good point, because you're using not even a Raspberry Pi. You're using a Pi Zero.
Yeah, no, at first I was using a Pi Zero. And then, at first I was using a Pi Zero. Then I found I had to use a Raspberry Pi 3B Plus because I did need a little bit more power to control the servo motors.
Okay. So talk about the relationship between the Pi and what the servo motor is, because in my mind here, I think in the mind of the folks that are listening, I got a giant ass battery, excuse my French. I've got a hub motor, a Pi that's going to get a little bit of power off the battery here. What's the servo and the relationship between the servo, what it does, and then when does the wheel start, and how does that work?
Okay, so as I mentioned earlier, some wheel hub motors have an automatic brake system inside, electronic brake, but mine did not. It has a manual brake. So I had to hook up some wires to pull that brake system back. And obviously I needed to do this automatically. So I used a servo motor. I think it was a 60 kilogram servo motor per centimeter. Per centimeter. And then that servo motor will pull that wire back and then activate the brake system to stop the wheel from moving because it's going down a hill. This trash can is going down a slight hill, so I needed a brake system to stop it at the edge.
Oh, wow. Okay, so like when you're riding a bike and there's a big steel cable from the front handlebars and you squeeze something, you're pulling a cable and then really yanking against a brake. Exactly. So there's a physical brake here.
Right, exactly.
Wow, okay. And you're pulling, you said 60 kg. How big is that servo motor? And is there any concern that that's going to yank too hard or the torque is going to be too much? It's going to snap the wire or just twist things inside of a big plastic trash can?
I definitely wasn't worried about the wire. I know the wire can handle up to a crazy amount of pounds, but I can't remember the exact amount. So I wasn't worried about that for sure. The main thing I was worried about was the servo motor not being able to pull it back and hold it. So that torque strength that I needed was very high to pull that back. Because if the wheel is moving too fast, that you need more torque strength depending on how fast that wheel is moving. So that's the main thing I was worried about with that servo motor.
Interesting. And how did you decide 60 kg? Did you do all the physics and all the math, or did you just guess?
I did a little bit. I bought something that can determine how much torque am I pulling on. So I figured out how much it would take to pull the brake system back, and then I found out that I can buy a servo motor that would equal, or at least be close enough to where I can pull that brake system back with the motor.
Oh, interesting. Yeah. So you could measure, like you could pull the brake with your own hand.
Exactly.
And then measure how hard you're pulling on that. This is like really cool because my 14-year-old is taking physics right now and he's sitting around like, I'm never going to use this ever. And I'm like, this is like a whole class on the physical world and how you would decide these things.
I actually wish I paid more attention in school. And now I see that I needed a lot more. Before I thought I was always just going to be a programmer and that's it. But now I'm seeing that my hobbies and, different house things I got to do around the house, I actually need some of these math and physics formulas. And I kind of wish I paid more attention.
I did a whole blog post on how proud I was of myself when I installed a door. Or just just around the house stuff. Right now I'm literally updating my home network and it's going to involve cutting a hole in the drywall to get the wires out. Like yesterday, I pushed a new website live in Azure, right? Like I'm managing a production website and I'm freaking out that I'm going to mess up my drywall if I cut this hole wrong. You know what I mean?
I know that feeling all too well.
But I feel like I should be good at both, but they're such different, it's like making stuff, but it's not.
Exactly.
Okay. So the servo motor, how big is that? Is that fit in your hand big? I can't try to visualize this.
Yeah, it's about 4 inches, I would say.
Okay.
It's pretty big. It's pretty hefty servo motor.
Okay. So it's really about mounting this stuff in some kind of an enclosure that it
Mhm.
doesn't torque itself. I assume it's so strong, it could really rip itself out of whatever you plugged it into. So do you just
Yeah.
screw it into the thing? How do you make sure that it doesn't torque itself as opposed to torquing the brake?
Yeah, that was actually one thing I ran into. It actually took itself out of the I put a nail through the trash can. That plastic is actually really strong though. So
Hmm.
the first time I did it, I only had one nail inside of it, thinking that it was gonna hold it, but it actually pulled out and ripped the trash can a little bit. So the
Mhm.
second time I literally did 4 nails inside each slot of the servo motor and just drilled it in and put a nut underneath the trash can just to make sure it's sturdy enough. And then that actually held. So that plastic is a lot stronger than I thought it was gonna be.
Okay, that's good to know. I
Yeah.
imagine it being thin, but then at the same time, I've only had the same trash can for 20 years, so I
Right.
suspect they're pretty strong.
Yeah.
Okay. Hey, friends, I want to tell you about one of our sponsors, Text Control. They're not only the creator of the fully featured document editor library for .NET and Angular apps, but their libraries also have powerful PDF functionality. So you don't have to program PDF documents. You can make MS Word templates and then merge them with data, and that'll let you create pixel-perfect PDF and PDF/A documents. The best part is fillable form elements like text boxes and checkbox fields and drop-down elements, and you can add those easily to your PDFs and make filling out forms really simple for your users. And don't forget, TX Text Control gives developers a complete solution to handle PDF documents in any business process. So check it out. You can try it free. See the live demos at textcontrol.com/demos. Just that easy. textcontrol.com/demos. So the GPIO, the general purpose IO pins on a Raspberry Pi put out 5 volts. They're not for pushing voltage. They're not for pushing amps.
Mhm.
There's got to be some kind of a controller or controllers between these things. What's the relationship between the Pi and its pins and these motors, and how do you tell them what to do?
So I use pulse width modulation to trigger the servo motor. So the servo motor can't just have a signal coming out from it, a volt signal. It won't turn with that. I know a lot of other electronics, they will just have something to activate when the voltage is high enough.
Mm-hmm.
But for, say, a servo motor, you need to give it the direction. So to give it that direction is also, it's called the signal.
Okay.
So you need the signal to send it from the Pi to the servo motor. So as I mentioned earlier, the servo motor isn't actually connected straight to the Pi.
Mm-hmm.
The power is coming from the battery, but the signal is coming from the Pi. So that signal wire is connected to the servo motor, but the power is connected to the battery.
Okay, so let me repeat that back or paraphrase so I understand.
Okay.
In a naive way, like if I'm thinking like, oh yeah, you just like raise the voltage and the motor starts. That's
Right.
back in the day when you take a motor and a battery or a 9-volt battery and you're like, look, I touched the battery to the motor and it spins.
Exactly.
This is not that.
This is not that. No, it's not a
Okay.
regular DC motor.
Okay,
A
so
DC
you're
motor would do that.
Okay, a DC motor would do that.
You're right.
But even though this hub motor you have, it does use direct current,
Hmm.
it's not a straight DC motor in that like give it power and it'll spin arbitrarily in one direction
Right.
or
It
another
will not.
direction if you reverse polarity.
Right. It will not.
Okay, so you're sending a signal from the Pi
Hmm.
using pulse width modulation, PWM,
Right.
and you tell what to
I
start the motor.
So I send a signal to tell it to spin to basically turn to a certain direction. So you can't basically tell it to spin infinitely. So you tell it to spin 360 degrees, then you tell it to spin back 360 degrees.
Oh,
Or
okay. Okay, so you're giving it like 20 degrees left, like that
right.
level of. So that's much more advanced than the motors that we learned on in like school.
Yes, for sure. Yeah.
Okay, and are you telling that, is this Pi telling that to the motor or to an intermediary controller?
No, it's sending it straight to the motor.
Okay, so then what is the motor controller? What is the motor controller for?
That's a good question. The motor controller is actually to, if you don't have a smart computer like a Raspberry Pi or an Arduino, then you can use the motor controller to basically send that pulse width modulation signal. Or it can be an intermediary between the Arduino and the servo motor. But the Arduinos and Raspberry Pis can do it. They can send it by themselves.
Okay, so then alternatively, you've got motor controllers where you can pass in the pulse width modulation, and then give it power alternatively? Because I'm trying to
Yeah.
understand, like, you can't plug in the big battery to the Raspberry Pi because it'll burn it because it's got too much voltage.
Right.
Do you plug the battery into the controller, and then the controller is then in charge of handling the voltage off to the wheel hub? Or do you
Yes.
plug the battery directly into the wheel hub?
Yeah. So if you have a controller, then you'll plug the battery straight into the controller.
Okay.
And then the controller, I believe, can also, it's mainly for DC motors, so it can basically set a direction as well, or stepper motors.
Okay.
That can handle that as well, if I'm not mistaken.
No, that's cool. I mean, this is what's great though. Like, people might say, "Oh yeah, I think it works like this, or it might work like that."
Mhm.
What's great about making stuff, in my opinion, on YouTube, is I usually get it like, I don't know, 25% right,
Mhm.
and then, like, yeah, and this is kind of how I think the rest of it works. And
Yeah.
the audience will say, "Yeah, you got it right," or "You mostly got it right," and then they'll give me, hopefully, helpful tips and stuff. Because we're
Right.
not saying I'm an expert. I made a YouTube.
Mhm.
We're saying I think I'm doing all right. I made a YouTube, right? Like, you can't argue with success.
Exactly.
Like, you do
Exactly.
have a self-driving trash can,
Yeah.
which is a
Yeah.
different thing than saying I have a PhD in self-driving trash cans.
Right. Exactly.
You know what I mean?
Right.
Okay. So that's cool. So that makes me understand how the Raspberry Pi can tell a motor controller to offer voltage to the battery via the battery to the hub motor.
Mhm.
That's the Raspberry Pi trash can part.
Mhm.
How do you know when the garbage man is coming, though?
Okay, so this brings into the vision part. So most projects need some type of vision or some type of signal to tell it when to start.
Mm-hmm.
So what I chose to do is to have a camera sit right outside my window. Now this camera is just going to watch for when the garbage truck comes,
Mm-hmm.
and when it comes, it's going to tell the trash can to do its work. So it's
Okay.
basically going to send a signal to the Raspberry Pi. So it does this with I'm using a Jetson Xavier NX, which is another onboard computer sitting on my desk, and that Jetson Xavier NX is running a machine learning model, and that machine learning model is it's called a convolutional neural network.
Mm-hmm.
So I trained it on a bunch of other trash cans because I took a lot of data the weeks before.
Yeah.
So
I love that you said that. Like, I trained it on other trash cans.
Yeah, so I had it sitting on my desk for 2 weeks, and I trained a bunch of I collected a bunch of data when the garbage truck came, and then when I collected that data, I converted all those videos into regular images,
Mm-hmm.
because that's all a video is just a bunch of different frames of images. So I extracted all of those frames and converted them into images, and then trained my model with those images. And then when it came trash day, to test it out, I just ran that model on my Justin Xavier Next, and then when the garbage truck came by, it sent that signal out.
Ah, okay. Now the Jetson Xavier NX is an NVIDIA product. It's like
Right.
a little square. It's, again, it fit in your almost the palm of your hand.
Mhm.
Is this a PC, or is this a single tasked? What is this thing? It looks like a PC. It's got a HDMI and it's got USB and stuff, but I don't think it's like a desktop computer, is it?
It's not too far off. It has a graphics card. It has a CPU. It has RAM. It has USB ports, HDMI. So I mean, I would consider it a PC. They call it. I think they call it embedded computers. So it's pretty much the same as a Raspberry Pi.
Right.
So a Raspberry Pi could be considered a PC as well, kind of. I may be wrong about that, but
well, it depends on what a PC is, right? Like,
right.
if you can plug a keyboard into it and a screen into it, and you've got input and you've got output, I think that qualifies as a personal computer. But it seems to me like this NVIDIA Xavier NX is like, have you ever heard the term the intelligent edge?
Yes.
Like, this is an edge device. Like, you could put this in like a Safeway or like a Kroger's grocery store, and it could do vision stuff that you could do on a desktop. Like, you could have just taken a laptop, right, and put it out the window, right?
Exactly. Right.
Okay. Is there a reason that you chose to do this? Just an excuse to get a cool new gadget, that you didn't just take a laptop and point it out the window?
I don't like my MacBook just running and sitting near a window. My MacBook has a limited lifespan, so I want it to last as long as possible. Right now, I pretty much only use it for software development, and I don't want to have machine learning models running down my GPU.
Mm-hmm.
So whenever I can use my Jetson, I have like 4 different Jetsons. Whenever I can use them, I definitely use them.
Oh, wow. Okay. So
Yeah,
you're a fan of this product.
for sure. Yes, for sure.
Okay, cool. And it sounds like because it has that dedicated NVIDIA GPU, you did the training there. You didn't do the training in the cloud or on your PC. So it did both the training and the running of this model.
Yes, exactly. Yep.
Interesting. Do you think that you could train it on this and then have taken another Raspberry Pi and taken the trained model and like a little cheap webcam and done it? Or do you think you need the power of this device to do this work?
So yeah, I could have trained it on. I also have a desktop PC as well. So I could have trained it on either that or my desktop PC and then sent it to the Raspberry Pi. But I've done a few projects with the Raspberry Pi using machine learning, and it's just too slow. It's way too slow. I was getting about 2 frames per second or 1 frame per second on my last project I did with a machine learning model. So I don't like running machine learning models on my Raspberry Pi. So that's when I use something like a Jetson Nano or Jetson Xavier.
Okay. So what is the code that's running on that? Is it Python or is it, and then how does it talk back to the Raspberry Pi?
Yeah, so it's Python, uses PyTorch specifically. And that model was built with PyTorch, and it actually runs the inference as well with PyTorch. And basically, whenever it detects that a trash can passes by, it doesn't just detect it, because sometimes there's a lot of false positives. Because a car looks pretty similar to a trash can, right? Like if you compared a car in a tree versus a garbage truck, I keep saying trash can, a garbage truck. If I compared a car in a tree with a garbage truck, the tree may be like 2%, but a car, it may be like 30% close enough where it can determine it. So you have to set that, you have to set it to where, maybe I wanted to be 70% or 80%. I think I put it at 90% actually.
I see.
So yeah, so when it found an object that was 90% a match, then it would send that signal to a Raspberry Pi using a REST API.
Okay, so this percentage that you're talking about, this is a level of confidence. I'm 90% sure this is a real garbage truck.
Right, exactly.
So you're not just shooting trash cans at the UPS man.
Yeah, exactly.
Did you have any like bad, positives where it's like, oh yeah, that toddler is not a trash truck, and then you like shooting your garbage can at a child?
Surprisingly not. I collected, I think it was like 400 to 500 images. So I collected the data from the 2 weeks before, but I also collected data from Google Images because my garbage truck company is called Republic Services, so it's pretty easy to find images online. So I think altogether I collected 500 images, and that may not seem like a lot for a regular machine learning model, but I retrained MobileNet, which is a really big model and a really fast model as well. So you don't need as many images to train it to get a real high confidence score on an object. So I was reaching, I think the trash can was like around 95% when I ran it that day. So that's pretty high.
It's smart to do that on a specific company's truck too. So you're not just looking for a generic trash truck.
Exactly.
You're looking for the one that comes to your house, which probably has certain coloring and certain text on it, and that's all going to help increase confidence and not be hurting the FedEx drivers.
Exactly.
Okay. So then you said it uses a REST API. So both the Jetson Xavier that is watching out the window and the Raspberry Pi are on the Wi-Fi?
Yes, they are. Both of them are.
Okay. And then you just have like an IP address or a DNS name and you say, hey, run, go.
Yep. So I think on the Raspberry Pi I was using the Express server, which is Node. I'm more comfortable with JavaScript because I'm a front-end developer in my full-time job. So I use an Express server on the Raspberry Pi. And then I think on the Xavier side, I used a Python server. I mean, a Python request to send it to the Raspberry Pi. And I used Python on Xavier because the PyTorch model was already on Python. So once it's seen the garbage truck, it just sent that, request out to the Raspberry Pi.
How do you decide that it's going to stop? Because you've got the braking environment, you've figured that part out. How do you make sure? Did you just hard code it, or did you teach it to stop at the end of the driveway?
Yeah, so that was actually hard coded. That was pretty much the only manual process I had to do with this. So I basically just timed it, how long it would take to get to the curb, and then stopped it at the curb. I had a lot of ideas where I was going to use my same my same Justin Xavier looking out the window to determine when it's near the edge of the street. But I ran out of time, so I just completely just manually put that in. I think it was like 4 seconds or something like that, and then it stopped.
I see. So you could teach it. That's a good point. You could teach it about distance. You could do it time-based, but it also, you could teach it about the curb.
Mm-hmm.
You could train the curb and tell it when to stop, but then you'd need to decide how hard to pull on the brake to decide when to stop. That's almost a whole other part two.
Yeah, for sure. I could definitely see that being a part two.
What did the trash man think about this?
So the trash man didn't think much about it, but the recycling people had a ball with it. They was going crazy. They was having so much fun with it. It was like, you did a remote control trash can. He was like, how'd you do that?
Oh, they thought it was remote control, like you're sitting up there with a joystick.
Yeah, that's what they thought. Yeah. So they had a big ball with it. But the garbage truck guy, he just passed by it and he just looked at it. And they actually skipped it in the beginning.
Did it not go out far enough?
No, it didn't.
Let me ask you this though. When we make these projects, sometimes I keep them live, sometimes I don't. Did you literally sleep in one day and find that it totally worked and you didn't have to babysit it?
No, I didn't. I actually broke it after I shot the video and everything. When I got inside when I tried to get inside the trash can and get it to dry me, I actually broke the plastic piece underneath. So it's not even functional right now. I have to actually fix that.
That's actually such a thing, though. I have so much fun making these kind of projects. I made a trash detection application. Mm-hmm. So like basically I have a heat map of the floor plan of the house.
Okay.
On a DAC board, which is like a DAK board. It's basically an old TV with a Raspberry Pi.
Okay.
So I've got all the trash cans in the house. Then they turn red or green based on whether there's trash in them.
Mm.
And I have a proximity sensor in the lid of the trash can pointing down. So then when the trash gets towards the top, the proximity gets closer. And then I text my sons, go take out the trash. This worked great it worked great for weeks. Everything's great. And so I'm like, how can this not go amazingly?
Mm-hmm.
Well, it turns out that if you open the top of the trash can really fast, like little boys do, it will knock the proximity sensor off and into the trash.
Oh, no.
So they literally threw that away.
Oh, man. That sucks.
So it's like, oh, man. So it's like, do I get another proximity sensor and solve that? But that's the difference, right? That's how you take it from being an IoT project to being something you could sell. You got to go back to the drawing board, figure out how to make sure this thing doesn't break itself.
Mm-hmm.
Or get itself thrown away and move to the next stage and go on Shark Tank.
Right.
Yeah. What do you got planned for next? What are you going to build next for your YouTube?
I have a lot of things planned, actually. I have about 3 projects in motion right now. I think my biggest project to kind of piggyback off of this project is I wanted to do a self-driving office desk. Yeah. So I already have all the electric scooter things. So I wanted to try to put that inside. I want to try to make more use out of those because I spent a lot of money on all those different electronics. But I actually found out that the electric hub motor isn't going to be able to pull me anyway. So I'm thinking about taking a part of a wheelchair and then, get back to woodworking. I haven't done a woodworking project in a few months, so I want to figure that out. But
very cool.
Yeah. That's probably not my next project, though. That's going to be, 6 months down the line or whatever. But,
well, you're going to have a great time building it, though, and that's why we do these things.
Yeah, for sure.
Fantastic. You can check out Ahad Cove at youtube.com/Ahad Cove, AHADCOVE. I'll have links in the show notes, as well as links to the specific video and his GitHub, where you can get the code for the machine learning part of the trash bot. Thanks so much for chatting with me today.
Thank you so much, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.